Okay, so in this particular lecture, we're going to go over electrolysis and we're going to talk about how we can use the electrical energy to split up a chemical compound. Okay, so electrochemistry, the science that unites the electricity and chemistry. It is a study of transfer of electrons. So at this point, you have a very good concept about reduction and oxidation and what happens in each of the type of chemical reactions, right? So in the reduction, you have a gain of electrons, and in oxidation, you have a loss of electrons, right? So you have a very good foundation of reduction and oxidation, right? When we went over that in our lectures on redox. Okay, so basically, electrochemistry is about using electricity to split up an ionic compound. Take it, we have an ionic compound, right? And to split up the ionic compound into its individual constituent atoms, you need to have energy, right? And that energy is given by a battery, okay? So you need to apply a voltage that is provided by the battery, and that voltage provides the energy to separate the ions into the individual constituent atoms, okay? So just we'll just go over some terms which we'll be using frequently in electrolysis. So what is voltage, charge, and current? So voltage or the electrical potential difference is called as a voltage. So in simple terms, voltage is the energy per unit charge. Take it, the energy that each charge carries is termed as the voltage. It is also called as a potential difference. The electric charge is that which causes the electrons and ions to attract each other, right? And it is measured in coulombs. Current is the rate of flow of charge per unit time. Okay. So we have so before we move on, we'll just talk about how does electrolysis occur and what is the driving principle behind electrolysis. I'll just erase this. Okay. So electrolysis occurs in an electrochemical cell, right? An electrochemical cell is composed of a battery. So we have a battery, right? So in order to split up any ionic compound in electrolysis, we just need to apply a voltage, right? And that is provided by the battery. So the battery has two terminals. It has a positive terminal and it has a negative terminal, right? So we connect one of the metal strips or one of the electrodes to the negative terminal, and we connect uh, one of the metal strips to the positive terminal, right? So the negative terminal, these are electrodes, right? These are called as electrodes, which are connected to each end of the battery. And the electrode that is connected to the negative end of the battery is known as the cathode. Okay, this is called as the cathode, right? And we'll talk about why are they called cathodes and anodes. And obviously, you must have guessed the electrode that is connected to the positive terminal is termed as the anode, right? So this is termed as the anode. And when you submerge the cathode and the anode, let's just use a different color. So when you submerge the cathode and anode into a solution that is containing your compound, so okay, so let's use blue for the solution. So when you submerge these cathode and anode into a solution, right? So you form an electrochemical cell, right? This is an electrochemical cell. And obviously, the solution must be conducting. Okay, the solution must be conducting. So, okay, so the solution must be conducting for the electrolysis to occur, right? Because you need to transfer the electrons, right? And you need to have mobile ions in the solution. So, uh, let's go over the details of cathodes and anodes, right? So cathode and reduction. So if like we talked about the negative terminal being the cathode, okay? So if the electronic conductor gives up electrons to the ionic conductor, then the electrode is called as a cathode, okay? And the reaction is called as a cathodic reaction. The flow of electrons and ions at a cathode is shown in the figure below. The copper strip is the electronic conductor and gives up electrons to the ionic conductor, which is the uh, which is the copper 2 sulfate solution, right? So we talked about the negative electrode being the cathode, right? So the negative, I don't know, यहाँ पे क्यों इन्होंने यहाँ positive दिखाया है इसको, but it's actually the negative electrode, right? So just correct this. This is not actually positive. This is negative. So at the cathode, what happens is, since it's the negative terminal of the battery, so you can just remember that at this terminal, the positively charged ions, right, in the solution, the positively charged ions will gain electrons. Okay? And when the positively charged ions will gain electrons, what will happen, Aslan? Will they get reduced or will they get oxidized after gain of electrons?
Reduced.
Yes. Okay? So at the cathode, what happens? Reduction or oxidation?
Reduction.
Reduction. Okay? Exactly. So reduction occurs at the cathode, and there's an easy way to remember this. So you can just remember this as a red cat. Okay? Red cat. And obviously you would have guessed that at the opposite terminal, that is the positively charged terminal, the positive terminal of the battery. So what happens there? Oxidation, right? So oxidation happens at the anode. Okay? Anode, at the anode, the negatively charged ions, for example, chloride, will lose electrons and will get oxidized. So you can just remember that as anox. Okay? So remember the principle anox. Oh, sorry. Wait. Okay, so anox and red cat. Okay, just remember this. And that way you can easily, memorize okay, what happened at which electrode. Okay. Okay, the chemistry that takes place in the cathode is reduction. So we talked about this. During the reduction, copper is deposited on the metal strip, right? And solid metal appears as a product, right? We'll talk about this in a moment. Okay, what does this mean? The process of depositing a metal on a conductive surface is used in electroplating of silver in jewelry and flatwares. That's a practical application of electrolysis. We'll go over this in more detail as we in later lectures. So anode, remember anox. Anode is the negatively charged terminal. Sorry, anode is the positively charged terminal of the electrochemical cell. And what's happening is that at the anode, the negatively charged ions are losing electrons, right? So anode is the electrode at which the electrons are generated. Okay, a reaction occurring at the anode is an anodic reaction, and it's obviously oxidizing. So why does it say that it is a reaction occurring at the anode is anodic reaction, and an anode is an electrode at which the electrons are generated? Why? The reason is that when a negatively charged ion will get oxidized at the anode, right? So it will lose electrons. Obviously, it will lose electrons, right? And when it will lose electrons, so it will generate electrons, obviously. And those electrons will be carried over to the battery and will be given over to the a cathode where it will be gained by that positive charge ion, right? So it's kind of a cycle. Okay. So reaction result occurring at an anode is an anodic reaction, and the resulting chemical change is called as oxidation. So remember, guys, anox, right? You have to remember this anox, and then zinc, and yeah, and the reduction reactions always occur with oxidation reactions, right? So the electrons used in the reduction must come from the oxidation reaction, as we talk about later. So if oxidation is occurring at the anode, so if a compound is losing electrons at the anode, so it must, transfer that electron to the opposite side, right? So at the cathode, the positively charged ion will gain those electrons and it will be reduced, right? So the overall reaction is an oxidation reduction reaction, otherwise known as a redox reaction, right? So we'll discuss more about the principle of electrolysis in the next video.